Hello there, class. Well, we are down to the very end. This will be the last new material that I give to you for this school year. So uh, don't celebrate just yet, though. Let's finish this thing and do it well so that you are well prepared for Algebra 2. We want to make sure that you know what you need to know so that you will be in good shape. So buckle down. Let's do this. There's just a little bit of material left. Most of it, I do believe you already know. Okay. It's just that it's presented in a different form, and so it may look confusing. But actually, the concepts of math, basically, it's arithmetic, to be honest with you. Those concepts are already well in your mind. So we're going to start with some really simple things to remind you of how to deal with the addition and subtraction of fractions. So without further ado, we will get on with this and see if we can make sense out of it. So when you see two fractions like this, 2/3 plus 3/4, you know that you need a common denominator, right? How do you get that common denominator? Well, there are different fractions, so some denominators are maybe a little simpler than others. But one way that always works is that if you multiply the two denominators together, you will have a common denominator. Now, maybe it's not the least common denominator, but it would be a common denominator. So in this case, if we take 3 times 4, what's 3 times 4? It's 12, isn't it? So if 12 was chosen as the denominator that we're going to use, then we would simply take the first fraction, 2/3, and we would multiply it by 4 over 4. We multiply it by the number 1, okay? But now we have 12 in the denominator. And then we would take the second denominator, and second fraction rather, 3 over 4, and we would multiply it by 3 over 3. Okay? So we've taken the 2, 3, and 4, we've multiplied them together in each case. So notice right here, we've multiplied them together, and right here we've multiplied them together. Of course, what you do to the denominator, you must do to the numerator, otherwise you wouldn't be multiplying by 1, okay, and then the fraction would no longer have the same value. So, of course, you always multiply by 1. So 4 over 4, this right here, is 1. And 3 over 3 is also 1. So if you take 2 over 3 right here and you multiply it by the number 1, it's still 2 over 3, isn't it? Except now it's going to be written as 8 over 12. Okay, 8 over 12, but it's still equivalent to 2/3. So this is the procedure that we will use even when we have much more complicated looking expressions. We use the same technique, So don't freak out when you see something that looks a little more complicated, because actually it's just more of the same. You've seen this stuff before, you've done this stuff before. So don't think that it's really something new, because it's not. All right, so here we go. Let's go ahead and do this. So 2 times 4 is 8 over 12, plus 3 times 3 is 9 over 12. Or you can write it all as one fraction, 8 plus 9 all over 12. Okay? And, of course, eight plus 9 we know to be 17, okay, over 12. So that would be the answer to this problem, 17 over 12. Okay, there you go. So that's how you do with just simple numbers, okay? But what happens if you have rational expressions? If they're rational expressions, things that involve x, y, variables, expressions that involve variables. Well, you know what? You use the very same technique. It's just that you're now dealing with rational expressions, but you will do the very same thing. So let's take an example here and see if we can't make some sense out of this. Let me find a nice one. How about we take 3 over 7n plus 2 over 7n. Okay. Example number 1. Three over 7n plus 2 over 7n. Notice, what do we have? We have a common denominator already, don't we? Excuse me. We already have a common denominator. It's 7n. So we don't need to do anything except bring these two together. So this is going to be 3 plus 2 over 7n, or 5 over 7n. Okay? So there you've got your answer, 5 over 7n. Very, very simple little problem. Now let's try one that's just a little more tricky. How about this? 14r over 9 minus r. Example number 2. (14r) over 9 minus r, and from that we're going to be subtracting 2r over r minus 9. Now you look at these two things and you ask yourself a question. Well, what is the common denominator? One is 9 minus r and one is r minus 9. Now I showed you a little trick the other day. We're going to use it again here. Notice that the denominators, this guy right here and this guy right here, are the same except that they're flipped around. One's 9 minus r, the other is r minus 9. I much prefer to see r minus 9 than 9 minus r. Usually we write the variable before the constant. Okay, so what would we need to do to reverse this first one? How can we reverse these two terms? How can we turn them around so that it becomes r minus 9? You remember the trick that we used the other day? How do you turn it around? Well, simple. You factor out a -1. You factor out a -1. So let's do that here and see what we can come up with. So this becomes 14 14r over -1 times r minus 9. You may say, well, really? Yeah, try it. Multiply it out. What's -1 times r? Right here. -1 times r is minus r. Don't we have a minus r right there? We do. And then -1 times a minus 9 is plus 9. And we got a plus 9 right there. So it works. We factor out the -1 and it flips it around. And then we'll go ahead and write the rest of it. Subtract, again, 2r over r minus 9. Okay? And we're almost there. So this now becomes 14r divided by -1, which is -14r, isn't it? Over r minus 9. So this becomes minus 14r over r minus 9 minus 2r over r minus 9. What is -14r subtract 2r? This becomes -14r subtract 2r all over r minus 9. So what is that? -14 subtract 2 is -16. So we end up with, and we could write it like this, minus 16r over r minus 9. We could put the minus sign out front like that. So minus 16r over r minus 9. Okay, I hope that looks pretty decent. That's one way we could go about doing this problem. So again, the little trick is you can factor out a -1 to flip something around. Now we could have done it differently. We could have had, instead of r minus 9, we could have had 9 minus r. So what would happen, just for sake of discussion, to me this is a fine answer, nothing wrong with it. That's a fine answer, but what would happen if I had, instead of flipped this one, instead of flipping this one right here, okay, instead of flipping this one, what if I had flipped this one around and made it 9 minus r? Well, if I had made that 9 minus r, then I wouldn't have done anything to the first term. It would have been 14r over 9 minus r. And in the second case, it would become a plus right here, okay? Be a plus. It would be 14 plus 2r would be 16r over 9 minus r. So effectively, if I'd gone that route, we would not have this minus sign right here. We wouldn't have this minus sign. It would just be 16r over 9 minus r, which you can still do. If you factor out a -1 of r minus 9, it would become 9 minus r, and then a minus over a minus is a plus. A negative divided by negative is a positive, and you'd be back to 16r over 9 minus r. So you could go either direction. I kind of like the way I did it because I prefer r minus 9 to 9 minus r, okay? I guess it's a matter of choice. All right, let's move ahead and let's find another example. Okay, example number 3, notice our denominators, d plus 5 and d minus 1. Well, what we do when we had a denominator of 3 on the one fraction and a denominator of 4 on the other fraction, we multiplied them together. And we will do the same thing here. We will have d plus 5 times d minus 1. But remember, what you do to the denominator, you must do to the numerator. You can only multiply a fraction by the number 1, otherwise you've changed its value. So we're going to take d over d plus 5, and we're going to multiply by d minus 1 over d minus 1. Okay? So we're going to say take d, and we're going to multiply it by d minus 1. Okay? And we're going to be dividing all of this by d plus 5 times d minus 1. Okay? Then we're going to add 7 times d plus 5 divided by d minus 1. I'm going to do it in the same order, so I'll do d plus 5 first. D plus 5 times d minus 1. Notice we've multiplied by the number 1. Why? Because, why is it number 1? Look what happens. These could be canceled, couldn't they? D minus 1 over d minus 1 is just 1. D minus 1 divided by d minus 1 is 1. Obviously, we don't want to cancel them. Over here, we have d plus 5 and the d plus 5. Again, we don't want to cancel them, but that value, d plus 5 over d plus 5, is just 1. So we've not changed the value of the fraction 7 over d minus 1. It's still 7 over d minus 1, but written in a slightly different form. So now I can bring these two fractions together into a single fraction and work this thing out. So notice it's going to be d times d minus 1 plus 7 times d plus 5, all divided by d plus 5 times d minus 1. Okay? Simple enough, yeah? Now my last step is just to try to simplify this a little bit. Let's go ahead and multiply out the numerator and try to create probably just a trinomial, okay, in the numerator. So what's d times d? D times d, I'm multiplying now, distributive property. This times this, minus, this times this, and then 7d, I'm going to be just multiplying now. So let's start multiplying. What's d times d? It's d squared, right? Minus d, because d times minus 1 is minus d. Then I go plus 7 times d is 7d, plus the last thing, 7 times 5 is 35. All of this is being divided by what? All of this is being divided by d plus 5 times d minus 1. Okay? Collecting some terms in the numerator, minus d plus 7d is plus 6d. So this will become the following: d squared plus 6d plus 35, all divided by d plus 5 times d minus 1. There you go. That's your answer right there. We've added the two fractions together. By the way, you notice that my screen's working a little better today? Just a little tip. If your touch screen doesn't work very well, clean it. I did a little study and I found out that you know, having dirt on your screen, smudges, fingerprints, a little bit of oil, whatever, it tends to reduce the effectiveness of the stylus transmitting the charge to the screen. You know, there's some movement of electrons there that causes the thing to work, and if your screen is dirty, it kind of messes it up. So clean your screen and it'll work better. Okay, well, folks, I think that's enough for addition and subtraction of fractions. The reality is there are harder problems a little bit. Some require factoring in the denominator before you can go on. But honestly, this is the concept. I think you've got it. All right. Now we're going to talk about another topic called complex fractions. Complex fractions. What is a complex fraction anyway? Well, let's just take a look at something here. What if we had, let's take our same two numbers. Remember we had 2/3 plus 3/4? Remember that? What if I did the following? What if I said 2/3 divided by 3/4? Okay. How would you handle that? Let's go back to elementary school. 2/3 divided by 3/4. Oh, you say that's the one that we pick up the other fraction, the divisor, and we flip it over and we change the division to multiplication, isn't it? Isn't that what we did? We'd say 2/3, and we would change it to multiplication, and we would say invert and multiply times 4/3, wouldn't we? 2/3 would be now times 4/3, wouldn't it? This is what we would do, invert and multiply. However, you realize that this could be written in different ways. Let's just finish this off. This would be 8/9, wouldn't it? Now, we could write this in another way. We can write it as what we call a complex fraction. Notice how it could be written. We could write 2/3 in the numerator divided by 3/4. Does that bother anybody? Are you bothered? I hope not. This means division, doesn't it? This line means division. So we have 2/3 divided by 3/4. We use the very same principle. We'll take 2/3 and we will multiply by 4/3. You invert and you multiply. And you still get the very same thing. 8/9. Okay? So you invert and you multiply. Well, what if it was different? What if we did something like this? What if we did 2/3 and we divided by just 4? Are you confused? Does that bother you? Does it look weird? 2/3 divided by 4. Any number can be divided by 1 and it's still the same number, right? So any number is over 1. So 4 is the same thing as 4/1. So if it doesn't bother you, let's go ahead and write it over 1. What's the rule? Is 4/1 a fraction? Yeah, it's a fraction, although we don't normally write the 1 because we know that 4 divided by 1 is just 4. Okay, so 4 is 4/1 all the time. So we use the same principle. We will invert and multiply. So this will be equal to 2/3 times 1/4, which is equal to 2/12, or 1/6. Now, usually I don't take the 3 and multiply by 4 and get 12. I'll usually cancel if I can first. How many times does 2 go into 2? 2 goes into itself 1 time. 2 goes into 4 2 times. So I think this is easier because you have smaller numbers and it's already in a factored form here. So 1 times 1 is 1. 3 times 2 is 6. Okay? 1/6. Now, would it bother you if we wrote it as a complex fraction? What if I wrote it in the following form? 2/3 divided by 4. Uh-oh, that looks weird, doesn't it? But you know, it's the very same thing. 2/3 divided by 4 is 2/3 divided by 4/1. So you will just invert and you will multiply. Okay? You will invert the bottom fraction, make it 1 over 4, and multiply 2/3 by that. So it's the very same thing. Okay? Now, using those principles, we will deal with rational expressions. Okay? Very same principles, the very, very same principles, invert, multiply, and we will then start using these principles on rational expressions. Let's look for another example. Okay, in example number 4, we're going to take 2 divided by n, and we are going to, actually, no, I don't want to do that one. Okay, here's one that I think will be nice to begin with here. 2 1/3 divided by 1 2/5. Well, these are improper fractions. We're going to now flip them around by changing their form a little bit. So this is going to be equal to 3 times 2 is 6 plus 1, 7 over 3 in the numerator. We're going to divide all of that by 5 times 1 is 5 plus 2, 7 over 5. We're going to divide by 7 over 5. Okay? So we have 7/3 divided by 7/5. And again, you know what we do. We invert and we multiply. So this is equal to, I really made a mess out of this thing. Let me clean it up a bit. So this is 7/3 times 5/7. So you invert the denominator and you multiply. Notice that the 7's cancel out, don't they? And so what are we left with? These guys cancel each other. So we're left with 7 into itself goes 1 time, and into here 1 time. So it's 1 times 5, or just 5 in the numerator. And in the denominator, 3 times 1 is just 3. So it's 5/3, okay? 5/3. Or because they started by giving us improper fractions, we could do the same thing here. We could say, well, this is equal to 3 into 5 goes 1 time, and how much remaining? How much remaining? It goes 1 time and 2/3, right? And my screen's messing up. I need to, okay, goes in 1 time and 2/3. Okay, 1 2/3. So perhaps they want it given, you know, the problem might ask us to give it in the same form that we started with. Notice how we started with improper fractions up here. They might want an improper fraction for the end. So, yeah, we'll just give it that way. I would accept the answer in either way, though, by the way. I would accept 5/3. I would also accept 1 2/3. So no big deal. All right. Let's move on to another example. So take a careful look at this fraction. 6 over x minus 2, all divided by. So this line right here is our big dividing line, okay? This separates the two fractions. Divided by 3 over x squared minus x minus 2. Now, same procedure. Bottom fraction is inverted and changed, and the operation is then changed to multiplication. So notice that this will become 6 over x minus 2, and the whole thing will now be multiplied by what? By x squared minus x minus 2 all over 3. Okay? I don't really need the first parentheses. I guess I could take those out of there. Okay. So 6 over x minus 2 times x squared minus x minus 2 all over 3. So invert the bottom fraction and multiply. Okay? So we are taking these two guys here. we're flipping it over and changing it to multiplication. All right. Now, we can do some canceling, and possibly by factoring the upper right, we can then also cancel something there. Make sure before you start canceling that everything is factored so that you can see all the factors. Then you'll know if something can be canceled. So to begin with, let us take the 6, and if you like, we can write it as 2 times 3. And in the second fraction, it's going to be, and this is all over x minus 2 before we go on, times, in the second fraction, we're going to have the following. Okay. X times x is x squared. 1 times 2 is 2. And it's going to be minus and plus, right? Why? Because the center term is negative. Therefore, the bigger of these two, when I say these two, the outer and the inner, the bigger of those two needs to be negative. So the minus 2x is the one we want to have negative. And this all, of course, is over 3. Now, we can cancel. Okay? At this point, you might want to make it more clear. You can put parentheses here. And incidentally, since it's multiplication, it can all be joined into one big happy fraction. Let me show you. It can be 2 times 3 times x plus 1 times x minus 2, all divided by 3. I'm changing the order of the multiplication in the denominator. You can multiply in any order. 3 times x minus 2. Okay? Now we can do what we've been longing to do. We can cancel the 3 into itself, goes 1 time, so they cancel out, and then the x minus 2's cancel out. So what are we left with? Now it looks pretty simple. We're left with 2 times x plus 1, all divided by what? What's left in the denominator? Nothing except 1. 1 is left in the denominator, so it's just 2 times x plus 1, which I think looks a little better if we write it as 2x plus 2. Okay, there you go. Final answer, 2x plus 2. Very cool. Fun problem. I hope that you enjoyed it as much as I did. That's a nice problem. Let's find another one. Ooh, here's an exciting one. Look at this. Now that's a complex fraction, isn't it? You have a fraction in the numerator and a fraction in the denominator. Notice one little thingy here. It's 2 plus q. Based on the way everything else is written, we would expect that would more likely be written as q. Well, we can write it around, can't we? I mean, it's not subtraction, so we can easily write that as q plus 2. 2 plus q is q plus 2, isn't it? You can add in any order. Subtraction, on the other hand, is a different matter. You cannot subtract things in any order, but you can add things in any order. So 2 plus q is the same thing as q plus 2. So why don't we turn that around? Secondly, before we do anything else, why don't we factor? Let's factor. Notice in the numerator, we have q squared minus 4 in the denominator. That is strangely familiar, isn't it? Doesn't that look like the difference of 2 squares in the numerator there? Doesn't this look like the difference of 2 squares? Yeah, that's the difference of 2 squares. So let's go ahead and factor those things and then simplify a little bit. So let's write our big divisor going through here. Boy, this looks terrible. Let me clean this up a little bit. Get my pen to write. I need to clean my screen again. All right, so this is q plus 2 over this. Q plus 2 times q minus 2. Difference of 2 squares. A squared minus b squared is a plus b times a minus b. So this is q squared minus 2 squared. q plus 2 times q minus 2. In the denominator, q plus 4. And then down here, in the denominator of the lower fraction, we potentially can factor this. Factors of 8 are 2 and 4, or 8 and 1. Let's think here for a little bit. So you think about the factors of 8, they're 2 and 4. Since it's positive 8, it's either a positive times a positive or a negative times a negative. So you add the two factors together. 2 plus 4 is 6. It works out. So let's go ahead and factor this thing. Q minus 2, Q minus 4. Right there we have it. Okay. Now we invert and we change the division to multiplication. Which fraction do we invert? Are you confused? This is the one we flip over right here. And this division right here will be changed to multiplication. Okay. So I'm going to have to move to the left side of my screen in order to fit everything on here. So I'm going to put my equal sign over here now so I can keep going. So q plus 2 all over q plus 2 times q minus 2 . Okay, that's my numerator. And then I'm going to be multiplying by the second fraction flipped over. Q minus 2 times q minus 4 all over q plus 4. There we have it. Just to make it look better, let's put parentheses there. Let's put parentheses here. And you realize now I can remove that dot that shows the multiplication. I can get rid of this guy right here and just write it as one big happy fraction, because it's numerator times numerator, denominator times denominator. And so I can just join these two together right there if I want. Okay, that would be perfectly fine. What can we cancel? You see anything that we can cancel? Well, sure enough, here in the first fraction, we can already cancel this. Those are gone. Then look at this. We can cancel these guys. Q minus 2 and Q minus 2. And what are we left with? Q minus 4 over Q plus 4. Okay? Q minus 4 over Q plus 4 would be our final answer. Okay, let's write this down then. Q minus 4 over Q plus 4. There you have it. Okay? Simplified. Boom. Okay, this is how we deal with complex fractions. Factor, get things factored out. Invert, multiply, cancel what you can cancel, simplify it down to a simpler form. And essentially, that's all there is to it. Whoa, look at this. At last, we come to solve. Solve for x. At last, we've come to the heart of the matter, which is solving problems, solving equations. So we're not just simplifying expressions now. We are looking for the variable. What is x in this particular situation? I hope that you see that this is simply a proportion. We have two ratios equal to each other. What does that mean? Cross multiplication works really well here. No problem. You can cross multiply. So notice that 4 times x plus 1, 4 times x plus 1 will be equal to 2 times x. Isn't that slick? Let's multiply 4x plus 4 equals 2x. Oop, not 24, 2x. Where did I get 24? Sometimes my brain does funny things. Okay, here we go. Let us continue on. We are now going to collect our terms. If we bring the 2x to the left, if we bring this guy over here like this, what will we have? We will have 4x minus 2x plus 4 equals, what's left over there? 0 is left because we took the 2x away. And then we will take the 4 to the other side. Okay, this is all review. You know this stuff. 4x minus 2x is 2x equals negative 4. Okay, and then divide both sides by 2. X will be equal to negative 4 divided by 2, which is simply negative 2. There you have it. We solved for x. Slick, eh? Slick, slick, slick. A lot of fun. I love solving math problems, don't you? What? Of course you love solving math problems. You just have to convince yourself that it's fun. And the more of them you do, the more fun it will get. All right, let's do example number 8. Example number 8, look at this. 2 over 3w equals 2/15 plus 12 over 5w. Aha, well, you know what, guys? There's more than one way you can go on this problem. We could, for example, if we wanted to, we could try to get a common denominator right here between 15 and 5w. Okay, we could try to get a common denominator so we get one fraction on the right. If we got a common denominator, we could bring that together into one fraction. And then we would have two fractions being equal. We'd have 2 over 3w equals some other fraction here on the right. We could cross multiply and do exactly what we did in the last example. That is one method, and it will work, no problem. You can do that. However, there is another method, and that is to multiply everything by the LCD. What is the LCD? Let's take a look for a little bit. The least common denominator. Well, 3 goes into 15, 5 goes into 15, right? And of course, 15 could be written with a W beside it there. 15W over W. Sorry, I didn't say that right. Never mind, scratch that. We can just multiply all these together to get the least common denominator, which is going to be equal to 15W, isn't it? 15W. So let's multiply everything by 15W. Okay, so let's say this is equal to, I'm running out of space here, so I'm just going to write this underneath. Let's multiply everything by 15W and see what happens. You know, if you remember the rules for equations, what you do to the left, you do to the right. If we multiply the left by 15W, we would have to multiply the right by 15W, and not just part of the right, but all of the right. So it's going to be 15W times parentheses 2 over 15 plus 12 over 5W. So we will multiply both sides by the LCD, which is 15W. So let's go ahead and do this. 15W times 2 over 3W equals 15W times the whole thing here, 2 over 15 plus 12 over 5W, like this. Now, why am I doing this? Because it allows the fractions to cancel out. So let's go ahead now and cancel what we can cancel. 3, the W's first of all cancel here. And then 3 goes into 15 5 times. It goes into itself once, and it goes into 15 5 times. So in the numerator now we have 5 times 2, or simply 10. In the denominator, there's just 1 left because both the 3 and the W canceled. Equals, now, distributive property, 15W times 2 over 15. The 15s cancel, and we're left with 2W. Okay, so the 15s cancel. And then when we multiply by the second term, plus 15W times 12 over 5W. The W's will cancel. 5 goes into 15 3 times, so it's going to be 3 times 12. Think about that for a little bit. 5 goes into 15. 5 goes into here once. 5 goes into here 3 times. The W's cancel. So you have 3 times 12 left. Okay? 3 times 12 is what remains. Get rid of all those cancel marks because, remember, it's distributive property. So, yeah, Okay, so here's what we're left with. So 10, whoops, get back to my red color. 10 is equal to 2w plus 36. Bring the 36 to the left and flip it around. So 2w will be equal to 10 minus 36. 10 minus 36 is negative 26. Divide both sides by 2, and we're down to an answer, negative 13. W equals negative 13. What an exciting problem. Why don't we do it the other way as well, just to show you how you can go different directions. Okay, here the problem is again, and let's now get a common denominator on the right and get this into one fraction on the right side of the equation. So we will now have 2, okay, let's do this, come on screen, write for me, 2 over 3w is equal to, now we need 15w as our common denominator, right, on the right. We're going to want 15w, so we're going to say 2 times w over 15 times w. We multiply by the number 1. Notice w over w, if you like. It looks really bad. This is the number 1. So we're multiplying by the number 1. 2 over 15 times 1, which will be represented as 2w over 15w. Okay. And then we are going to take the second term, and we're going to multiply by 3 over 3. Okay, so it's 12 over 5w times 3 over 3. Okay, so what is now left on the right? On the left, it's just 2 over 3w. On the right, we have 2w plus 3 times 12 is 36, all over 15w. Very cool. Now, let us cross multiply. Let us cross multiply and see what we get. This is getting exciting, isn't it? Okay, well, this is getting exciting. Now we cross multiply, and this is a messier method, so I wouldn't necessarily recommend it, but I want to show you that it will still work. We can cross multiply. So on the one side, we will have 3w times 2w plus 36. And on the other side, we'll have 2 times 15w. 2 times 15w is 30w, so we have 3w times 2w is 6. In fact, before we do that, why don't we divide everything by 3 right here? Divide everything by 3, it will simplify the numbers. If you divide the left by 3, the 3's cancel, so you're left with w times 2w plus 36. And on the right, if you divide this by 3, 3 into 15 goes 5, 5 times 2 is 10. You'll get 10w. Okay, this is a little simpler. Multiplying now, we can get 2w squared. Okay, notice it makes a quadratic out of this. 2w squared plus 36w equals 10w. Okay. And at this point, we can bring the 10w over to the left. In fact, we can divide everything by 2 again if we want. If we divide everything by 2, 2 into 2w squared just is w squared. 36 divided by 2 is 18. And 10 divided by 2 is 5. Now bring the 5w to the left. What is, this is w squared plus 18w minus 5w is what? 18 minus 5 is 13. Okay, equals 0 now. We leave a 0 on the right. Factor out a w here, and you get w times w plus 13 equals 0. Now, you know there are two ways you can get this answer. You can have w equal to 0, or you can have w plus 13 equal to 0. And if w plus 13 is 0, w would be equal to negative 13. There's the same answer we had before. What about this w equals 0? Well, if you come up here and you look, w cannot be equal to 0 because it would be division by 0, way back in the original problem. This would be 2 divided by 0 equals 2 over 15 plus 12 over 0. No, w equals 0 is not allowed. That is not a permissible number. So we cross this one out. We say no, w cannot be equal to 0. So we have w equals negative 13. Well, you know, this introduces a quadratic equation, which really is not the simplest way. The simplest way is to do what we did right up here at the top, multiply everything by the LCD. Very important. Multiply everything by the LCD, and that eliminates the fractions and cleans things up right at the very start. So a much better way to go, right? W equals negative 13, and two methods to go about that problem, one being much easier than the other. Okay, let's look for another example. Oh, and one thing, before I forget, there's a name for this guy right over here. This guy right here has a special name. It is called an extraneous solution. An extraneous solution is a solution that's not allowed. It's an extra solution that gives 0 in the denominator. So this is excluded from the domain. W cannot be equal to 0, and it's called an extraneous solution. Okay, now back to what we were headed for, our next example. Okay, example number 9 brings up a really good point that you need to take note of and do not forget. Before you look for the LCD, before you look for the least common denominator, which you will then use to multiply both the left and the right side of this equation, which would then eliminate all fractions, before you look for that LCD, make sure that all the various factors that you're looking at are in factored form. So for example, in this problem, if you take a look, this guy right here, x squared minus 1, does that look familiar? Come on, somebody. Does it look familiar? Yes, it does. It is the difference of two squares. Well, you say is 1 a square? Yeah, 1 squared is 1, isn't it? 1 can be written as 1 squared. So this is x squared minus 1 squared, which we'll factor as x plus 1 times x minus 1. Make sure that everything is in factored form before you head off to find the LCD. So this guy will be x plus 3 divided by x plus 1 times x minus 1, okay, minus 2x over x minus 1 equals 1. Okay, now should be a little easier to see what the LCD is now. The LCD is x plus 1 times x minus 1. We already have the LCD on the first fraction here on the left side. X plus 1 times x minus 1 is our LCD. So let's write that down. LCD, x plus 1 come on, my screen. Messing up again. Come on, right. Okay. LCD. Hey. And on top of everything else, I've switched to blue somehow. Okay, let's try again. LCD. X plus 1 times x minus 1. There we go. But that's what we're going to multiply everything by. Everything gets multiplied by that. So we multiply the first term, and it will cancel out. But let's go ahead and show this. We're going to go x plus 1 times x minus 1, and we're going to multiply the left side by this. So I'm going to use a big bracket here. I'm going to put x plus 3 over x plus 1 times x minus 1. Okay, subtract 2x over x minus 1. Okay, big bracket equals 1 times x plus 1 times x minus 1, which is just x plus 1, running out of space. Come on. X plus 1 times x minus 1. There we go. We can fit it now. Oh no, don't tell me I've gone off the screen. Well, I've gone off the screen, but I think you know what's there. So we will go ahead now and try to simplify this just a bit more. All right, so on the left, when I multiply this guy, x plus 1 times x minus 1 times the first term, I use distributive property. It's this guy times this minus this guy times this, okay? Distributive property. X plus 1 times x minus 1 times the first term simply leaves x plus 3 because the denominators canceled, okay? These denominators here cancel out when I multiply, and I'm just left with x plus 3, okay? So I can't cancel them yet, though, because I've got to multiply by the second term, right? Can't cancel that out of there. I need to continue multiplying. Okay, so x plus 3 is my first term. Okay, minus x plus 1 times x minus 1 times the second term. The x minus 1's cancel, and we're left with 2x times x plus 1. So minus 2x times x plus 1 equals x plus 1 times x minus 1, because that's all that's over on the right. Okay. Now what do we do? Oh, wow, it's getting exciting, isn't it? Well, what we need to do is to multiply everything out and collect terms. This is going to leave us with a quadratic equation. If we're lucky, it doesn't look like we're going to be lucky. Sometimes you'll see like an x squared on the left and another x squared on the right. If you subtract x squared from the left and the right, they cancel out and you're good to go. In this case, though, it's not going to work. We're going to be left with a quadratic equation. So we have x plus 3, okay, minus 2x squared, okay, minus 2x equals, multiplying the right, this is the difference of two squares, it's going to be x squared minus 1. X squared minus x plus x minus 1. Should I multiply that out? Probably I should, in case somebody's a little confused. Let's make sure that everybody's together. So x squared minus x plus x minus 1. Okay, so x plus 3 minus 2x squared minus 2x equals x squared minus 1. Bringing all the squares to the left, in fact, let's bring everything to the left, bringing everything to the left side of the equation and collecting terms. So we have minus 2x squared, subtract the one on the right, minus another x squared, okay, That takes care of this one and this one. Okay. Now let's collect our x's. Let's collect all of our x's. Plus x minus 2x. That takes care of this one and this one. Sorry, it's supposed to be in blue. That takes care of this one and this one. X and the 2x. Okay, plus x minus 2x. Then we do our constant plus 3 plus 1 from the right. Let's do our accounting now. We took care of that one and that one. Equals 0. Okay, bring everything to the left. Everything to the left. Should have taken care of them all. Collecting terms now. Minus 2x squared minus x squared is minus 3x squared. Okay. Plus x minus 2x is just minus x. Plus 3 plus 1 is plus 4 equals 0. Now, personally, I don't want that minus sign up there in front of the 3. I don't like it to be minus 3x squared. I want it to be positive 3x squared. So I multiply both the left and the right by negative 1, and that gives me 3x squared plus x minus 4 equals negative 1 times 0 is still 0. So I flip all my signs, and now I'm ready for the big test. The big test is factoring. Let's see if we can remember how to factor. What are the factors of 3? What is the matter with my screen? Sometimes I get so frustrated. Guys, I need a graphics tablet. If I had a graphics tablet, this would work great. We'd be in good shape, but I don't have one, so sorry about that. So what are the factors of 3? Hey, it's doing it to me again. What are the factors of 3? 3 times 1. What are the factors of 4? Well, the factors of 4 are 4 times 1, 2 times 2, and 1 times 4. And it's negative 4. So it's either going to be a plus times a minus or a minus times a plus, isn't it? And the centered term is positive, and it will be the difference of the two factors, of the outer and the inner, actually, I should say. Outer plus inner has got to be a difference because the center term is positive and the last term is negative, okay? So let's see what we can work out. Let's look for 1 as being the difference. You may be a little lost right now. It's 1x. So I need 1 out of the outer and the inner here. So the outer on the first one, 3 times 1. I'll try to mark what I'm doing. 3 times 1 is 3, and 1 times 4 is 4. 3 and 4 has a difference of 1. Hey, what do you know? That's going to be our guy right here. This is going to work for us right here. Okay, just to illustrate though, 3 times 2 is 6, 2 times 1. So I'm doing this one. 3 times 2 is 6. 1 times 2 is 2. And the difference between 6 and 2 is 4, not 1. So the first one is definitely the one we go with. So let's go ahead and make our parentheses and factor this. Three x and x, okay? And then 4 and 1 in that order. 4 and 1. And let's think about the signs now. The center term is positive, so what's bigger? 4x or 3x? The bigger one is obviously 4x. So we're going to need to have that to be the bigger one should be the positive one. So this is going to be positive and this will be negative. Okay. Now, we're ready to solve. This is a product of two factors, this times this, equal to 0. So either, number 1, 3x plus 4 equals 0, or x minus 1 equals 0. And in the first case, it would be 3x equals negative 4, or x is equal to negative 4/3. In the second case, x would be equal to 1. Now, are either one of these things prohibited? Is either answer no good? Go back to our original problems where we answer that question. We come right back up here to the start and we say, do any of these give 0 for a denominator? Okay, do any of these give 0 for a denominator? X equal to 1. X equal to 1. Sure enough, if x was 1, if you put a 1 right here, then you'd have 1 minus 1, which would be equal to 0, wouldn't it? So x cannot be equal to 1, even though we have a solution that says x can be equal to 1, but we know it would create division by 0. So therefore, hey, come on. Therefore, this one is not allowed. This one is not allowed. This is division by 0. Okay, division by 0. And what is this called? X equal to 1 is what type of solution? It's an extraneous, remember that? Solution. Which is really to say it's not a solution at all, right? Doesn't work because it's division by 0. So what's our final answer? X equal to negative 4/3. Checking again, does negative 4/3 give us 0 up here? No, it does not. We're good to go. X equals negative 4/3. That's the solution. What example was this? To number 9. X equals negative 4/3. Very, very cool. Another example. Okay, example number 10. We have a function, f of x equals x squared minus x minus 30, all divided by x minus 6. Now, what type of a graph do you suppose this would have? If you look at the numerator, it's x squared minus x minus 30. That is a quadratic equation, isn't it? Yeah, it's a quadratic equation. So you know that the graph of the numerator is a parabola, isn't it? And it's positive 1x squared, so it's opening up. So we know that that would be a parabola, but notice we are dividing by x minus 6. So when we divide by x minus 6, it's possible that something will get canceled out. And this would no longer be a parabola after the cancellation. So let's go ahead and see if we can factor the numerator. See if this makes any sense to you. Let's go ahead and factor the numerator. Okay, so this will be equal to the numerator, and this one does factor, so it's x times x gives x squared, and factors of 30 are 5 and 6, right? And the difference between 5 and 6 is 1, the center term, but the larger of the two, 5x and 6x, the larger of the two must be the negative sign. So we put minus here, and we'll put plus over here, and we have x minus 6 in the denominator, okay? Now, as you can see, the x minus 6 is the same top and bottom, so it cancels out. And what are we left with? We're left with f of x equals x plus 5. What does the graph of x plus 5 look like? Do you recognize this form, x plus 5? Does it look familiar to you? How about if I change that f of x equal to y? Y equals x plus 5. Does that look a little better? What? You're still confused? You can't remember? Here, y equals mx plus b. What's the slope of this line? 1. What's the y-intercept? 5. In fact, if you come back over here to the graph and take a look, you will discover that in fact it is a straight line. But before I go to the graph, I want you to look up here at the top and take note that we are dividing by x minus 6. There is a value of x for which we are not allowed to include in the domain. We're not allowed to include x equals 6 in the domain because if we had x equal to 6, we would have 0 in the denominator. So even though after cancellation of everything, we have a straight line, y equals x plus 5, we must remember that when x equals 6, we have an undefined situation. So let's take a look at the graph and see what we have. I've already put it in here. X squared minus x minus 30 divided by x minus 6. Notice it is a straight line, just as we expected. The slope should be 1 and the y-intercept should be 5. So let's zoom in on this and see if we can get it a little closer to where we can see. What's the y-intercept right here? 5, isn't it? 4, 5, 6, 7, 8. So it is 5. I zoom in a little more, you can see it even better. Is the slope equal to 1? Okay, is the slope equal to 1? Well, when I start off, just like somewhere here, notice, as I go up, here's 0, 5. If I go over 1, it should be 1, and then up 1 should be 1, 6. Does it go through 1, 6? Sure does, it goes through 1, 6. So notice it's over 1, up 1, over 1, up 1. The slope is 1, and the y-intercept is 5. Now, there's something else very important to take note of here, and that is that x cannot be equal to and cannot be equal to 6, because when x equals 6, we have 0 in the denominator. Remember what I said. Back here to our guy right here, the part I circled in blue up here, this one, x cannot be equal to 6 because 6 minus 6 is 0, so we cannot have 6. And does the graph bear this out? That's the question. Well, here's 5, here's 6. Let me center this up a little better. So if we start running along this graph, here we are at -5, x equals -5. Let me get a mouse so I can do a little better with this. Okay, here's my mouse going now. Hold on just a second. Got to reposition things, my computer, so I have a mouse space for my mouse. Okay, here we go. All right, so as I move up along this graph, notice I'm starting at -5. And then we go to 0. And then we go to 1. Right here is 1, 6. This should be 2, 7. Sure enough. 3, 8. 4, 9. 5, 10. See that number? What is going to happen when we get to 6? Remember, x cannot be equal to 6. What happens when we get to 6? Watch carefully. Watch what happens when we get to 6. We're almost there. We're almost, oh, look at that, look at that, look at that. 6, undefined. Undefined is the y coordinate. It's undefined, and the red dot went to an open circle. See the open circle? Now, for the A students, or anybody that wants to shine, tell me, what is the name to describe that particular open circle point on this graph? What is it called? Come on, come on, come on. I can't hear you. Shout. Removable discontinuity. Yes, it's a removable discontinuity. It's an open circle on this graph that is prohibited because it creates division by 0. Now, one last question. This particular problem, they wanted to know what is the 0 of the function. In other words, when is y equal to 0? Okay, back here at the graph, take a look at this, at the equation, sorry. We have y equals x plus 5. So if you were to set this equal to 0 and solve, you would answer that question. What if we said 0 equals x plus 5? Then what value of x creates 0 here? Well, we would know that x would be equal to negative 5 if we are looking for a 0. X would have to be negative 5. So there's a couple of things here that we would do. First, to simplify. So there's the simplified function after cancellation, after factoring and cancellation. The second thing, we needed to identify the 0. And here's the 0. Actually, the 0 point would be negative 5, comma 0. That would be the point on the graph, negative 5, comma 0. Back to the graph. Let's follow this thing right on down, 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 down. We're getting close to 0. 1, now less than 1, getting less than 1. We're at 0.5 now. Coming on down, coming on down. Oh, wow, look at that. Negative 5, 0. Isn't that what we said? Negative 5, 0? Yes, negative 5, 0. Right here. Negative 5, 0. Negative 5, 0. And there it is, sure enough, on the graph, negative 5, 0. All right, that's example number 10. I'm going to do one more of these graphs, one that's slightly more complicated, to see if we can make this really get real for you, so that you end up Algebra 1 with a really strong understanding of graphs and all these things. So here we go to example number 10. Oh, no, number 11, sorry. Okay, example number 11, f of x equals x cubed plus 6x squared plus 12x all over x. Now, we divide everything by x, we can cancel out some x's because every single factor in the numerator, or every single term, I should say, in the numerator has x as a factor. So if we divide this, we get the following. We will get x cubed divided by x is x squared. Plus 6x squared divided by x is 6x. Plus 12x divided by x is just plus 12. Now, what type of an equation is this? F of x equals x squared plus 6x plus 12. Is this not a quadratic equation? And is the graph not a parabola? Well, it is a parabola, and yes, it's a quadratic equation. Let's see, will it factor? Just out of curiosity. Will f of x equal x squared plus 6x plus 12? Will it factor nicely? Let's see if we can make this thing factor. And if it does factor, we can easily find the zeros. If it didn't factor, can we still find the zeros? Somebody. If it didn't factor, can we still find the zeros? Yes, we can. What methods could we use? Quadratic formula. Did I hear somebody say that? Yes, you can use the quadratic formula. You could also complete the square. Both of these methods would allow us to find the zeros of this function. Factors of 12 are 2 and 6. That would be a sum of 8. 3 and 4. That has a sum of 7. Uh-oh. It's not going to work out nice, is it? We could use the quadratic formula. That would allow us to solve it. Okay, so this particular quadratic equation will not factor nicely for us. So I can just get rid of these guys because they are of no use here. I can get rid of the parentheses because I'm not going to factor it. Now, one thing, when it doesn't factor, you can start to ask yourself, well, maybe there's something else going on here. So a good thing, before you jump in and use the quadratic formula, a good thing to check is the discriminant. You remember the word discriminant? The discriminant is equal to the following. If I can remember how to spell discriminant. D-E-S, discriminant. Anyway, the discriminant is equal to the following. Equal to b squared minus 4ac. And if b squared minus 4ac is positive, you have real roots. But if it's negative, you don't. Okay, what is b? What is a and what is c? b is equal to 6. So this is going to be equal to 6 squared minus 4 times 1 times c, and c is 12. 4 times 12 is 48. So notice we have already discovered something important here. We've discovered something important here, and that is that this is equal to 36 minus 48, which is equal to negative 12. The discriminant is negative. So therefore, we know that there are no real solutions. No real solutions if we're looking for zeros. And remember, solutions and zeros are the same thing. So really, I should have shown one more thing up here. I should have done the following. Would have been, I think, more clear for you. I should have done the following. I should have said 0. Find the solutions. I should say 0 equals x squared plus 6x plus 12. And if I'm trying to find zeros, then I do set it equal to 0, but the reality is there are no real solutions. Now, what does no real solutions actually mean? That means that the parabola does not cross the x-axis. Because if it crossed the x-axis, you would have zeros, right? If it crossed the x-axis, you would have zeros. But this parabola does not cross or does not touch the x-axis. Now, we can graph it to prove that, to see it, and I think that will add a little more clarity to it. But coming back up to the very top, if we were to put this thing in here, x cubed plus 6x squared plus 12x all over x, if we put this into the Desmos graphing calculator, we should see a parabolic graph, but also we should see that there are no real solutions, meaning it does not cross the x-axis. We should also see that there is a removable discontinuity when x equals 0, because x cannot be 0. Remember, if x is 0, we'd be dividing by 0, and that's not allowed. So a removable discontinuity at x equal to 0. Let's jump over to the Desmos graphing calculator and see for ourselves if this is in fact the case. Okay, well, here we are. I've entered this equation, x cubed plus 6x squared plus 12x all divided by x. I've entered it here. F of x, remember, is replaced with y, and you can see the graph. Number one, notice that it does not cross the x-axis. Okay, it does not cross the x-axis. So if we try to come down with this graph here somewhere like this, notice it goes down, 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 down. With the minimum point, the vertex is right down here at negative 3, 3. But negative 3, 3 is still above the x-axis. Notice the x-axis is down here. We're still above and the graph opens up. That's why it has a negative discriminant. That means no real solutions. This graph does not cross the x-axis. But if we follow up, remember also x cannot be equal to 0. We should see a removable discontinuity when x equals 0, which is somewhere right about if I can get it, keep bumping my mouse. There. Notice, open circle, undefined. That's because x cannot be equal to 0 in the original equation. So there you have it. No zeros, meaning no real solutions. And simplified form is just x squared plus 6x plus 12. So, okay, enough for the graphs. Example number 12. Here we have some pretty complicated looking fractions, and we have an equality where we're going to have to solve for x. Now, the first thing we always do when we go to solve for x is to see that things are factored. When we're looking for a common denominator, we need to have things factored. So as we look at the denominator of the first term and the last term in this equation, we see that it is x cubed minus 2x squared, of which you can factor out x squared. So let's take a look at this and factor it out. So in the numerator now, we'll just leave that as it is for the moment. we'll just write this as x squared plus 5x minus 6. And we're going to put all of that over x squared times x minus 2. Okay? X squared times x minus 2 is in fact x cubed minus 2x squared. And that will be equal to 5 over x minus, and on this side, notice we have the same thing. It's going to be x squared times x minus 2. Now our denominators are all in factored form, and notice that the only thing missing on the denominator of the 5 here, 5 over x, this guy right here, if we were to multiply that by x times x minus 2, in other words, this right here, if we were to multiply it by x times x minus 2, we would have the same thing as all the other denominators. So our denominator then is in fact, the least common denominator is in fact equal to x squared times x minus 2. This is our least common denominator. We can multiply everything by this and we will eliminate our fractions. Just as simple as that. In other words, if we wanted this, the x squared times x minus 2 to be the denominator here that I have circled in yellow, we would just multiply top and bottom by x times x minus 2 and we would have it. So anyway, let's multiply through by the LCD. Multiplying through by the LCD. And I'll try to write small and see if we can't show this. It's hard when I don't have more space, but let's see here. X squared plus 5x minus 6. I'm going to take all this and we're going to it's over x squared times x minus 2. We're going to take all this and we're going to multiply it by x squared times x minus 2. Okay? And that takes care of the first term. Then we have equal to 5, and when we multiply it by x squared times x minus 2 over x, the x cancels, and we will have 5. The x cancels the square on the x squared above, and we'll have 5 times x minus 2. Minus, and then in the last term, it's going to be 6 over x squared times x minus 2. And in the numerator, we're multiplying by x squared. Actually, I don't need that parentheses because it's all multiplication. So it's going to be 6 times x squared times x minus 2. Like this. Okay. Now what I can do is cancel out everything that I can cancel. I cancel this and this. I cancel this and this. And I'm just left with the 6 there. Okay. And in this other one, this x cancels the square, leaving me just 5x up above. Okay. So rewriting again, simplifying down a little bit. This is now x squared plus 5x minus 6, and this is equal to 5x times x minus 2 minus 6. It's looking a little simpler now. So we will continue on collecting terms now. And we have to expand, we have to multiply out the 5x times x minus 2. So this becomes x squared plus 5x minus 6 equals 5x squared minus 2 times 5 is 10, minus 10x and then we subtract the 6 over there on the end. Now we collect all of our terms, and we can take them all to the right if you like, or we could take them all to the left. I kind of prefer taking them to the right so that we don't have the negative x squared. I don't know, whatever suits you, really doesn't matter. So I'm going to put 0 here. I'm going to say this is equal to 5x squared minus x squared. How am I getting this? I'm taking the x squared over here. I'm taking everything over, okay? Everything over to the right. And this one goes over to the right, and this one goes over to the right. Okay? Everything goes to the right. So 5x squared minus the x squared, okay, minus 10x, okay, minus the 5x, okay, minus 6, and then plus 6, and they cancel each other out. So in the end, I have 0 equals 4x squared minus 15x, and then these two, of course, have canceled each other. Now, this is equal to 0. So let's factor out the x that we can in this last term down here, last equation. Factor out x. X times 4x minus 15, okay, equals 0. So what are the possibilities for x? Either 0 times 4x minus 15, okay, or 4x minus 15 being 0 times x. So we have two possibilities. Answer number 1, x equals 0. That's one possibility. Or x minus 15 could also be 0. In which case, 4x would be equal to 15, or finally, x would be equal to 15 divided by 4. 15 divided by 4. Okay? So here are the two possible values for x. Now, if you look back at the original problem, you must always check for extraneous roots. In other words, you must check for roots that would give you 0 in the denominator. So you bring this back up here and you look carefully at the original problem. All right, back up here, where are we? Okay, this is the original problem right here. Okay, so you look and you say, if x was equal to 0, would we have 0 in the denominator? Yeah, we'd have 0 in the denominator, so that's not allowed. We have to disregard that value of x. X equals 0 gives us 0 in the denominator, which is not allowed. Therefore, our only option is 15 over 4. So let's go ahead and cross this guy out right here. Oops, sorry about that. Let's go ahead and cross this guy out. That's not an option. And so we know that our answer is right here. 15 over 4. X equals 15 over 4 is our solution. And again, it might be a good idea if I wrote extraneous root on here just to make sure that you understand. Don't forget this word. Extraneous. And my pen is not writing again. What a mess. Try one more time. This is what we call an extraneous root, the 0, because it gives 0 in the denominator. By the way, it could be any value, but any value that creates 0 in the denominator. It just so happens that in this case, the value is 0. Okay, So that's our extraneous root, and you have your solution. So this is how you solve equations that are a little bit more complicated. You multiply through by the LCD to eliminate fractions, and should take care of most of the situations you might meet. Well, that pretty much wraps it up. I think, we've been through essentially most of the book. We did well in coverage. We've made it all the way up to the end of chapter 11, which is better than we did last year. I'll just say that. You guys did better. So this is encouraging. Chapter 12 actually is, I think, pretty seldom done by ninth grade students. It's probability and statistics. Um, You'll have opportunity to do this again in Algebra 2, probably some in pre-calc as well. And then certainly if you take any like business or science in university, then you would probably take probability and statistics there as well. So going through chapter 11, I think has been pretty complete course for you. So now it's time to prepare for the test. I need to check, I don't recall what day the test was going to be on. Let me just take a look. So our exam is going to be either on Thursday afternoon or Friday afternoon of next week. So either 18 or 19, somewhere in there. So we have some time to review. I'm hoping that you guys will study diligently. I've recorded a really, really good video for this last one. I say good, you're not going to be happy probably because it's a bit long, but it, I think, does a very good job at explaining what needs to be explained. And my hope is that you will take it to heart, do your best, study, watch the video several times and watch other videos several times. So we're looking at a final exam coming up next week. And if you have a view of Moodle, you'll see that we have several things there that you need to go over. So let me just turn off the screen here and turn off my video so that you can see the screen. And let's take a look at this. Okay, chapter 8 dealt with factoring, remember? And you cannot forget how to factor. I mean, factoring is something that you're just going to have to know how to do. So make sure you can factor. That's chapter 8. Chapter 9, as you're seeing here, chapter 9 deals with quadratic functions and equations. So we were just doing some in this last video that you should be watching as I speak here. This video, we're going over a little bit of factoring and also quadratic equations. Remember, when we deal with quadratic equations, we're talking about the graph being a parabola. We have maxima or we have minima. When we're talking about those, we have zeros of the function. That's where the graph crosses the x-axis. We also have the discriminant, which tells us whether or not you will have real solutions or not. So we're talking here about b squared minus 4ac. Line of symmetry minus b over 2a. There's a lot of things that you need to go back and review from chapter 9. Okay, chapter 9. So we can solve either by graphing, by factoring, by the quadratic formula. Oh yes, the quadratic formula. Do not forget the quadratic formula. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. So do review the quadratic formula. Then, of course, we have chapter 10, radical functions and geometry. To be precise, trigonometric ratios, sine, cosine, tangent. SOHCAHTOA, remember SOHCAHTOA, sine, opposite over hypotenuse. Okay, cosine, adjacent over hypotenuse. And then finally, tangent, opposite over adjacent. SOHCAHTOA. Know how to solve triangles to find all the unknown sides and angles in right triangle trigonometry. All right, so also, of course, know how to simplify radicals. Remember, a radical expression is not simplified so long as you have a radical in the denominator. You must eliminate all radicals in the denominator to be in simplified form. Furthermore, anything under the radicand must not have a factor that has a nice square root. I guess you could be talking cube root also if you're dealing with cube roots, but mostly we were dealing with square roots. So make sure you bring outside anything that can be brought out of the radical, from under the radicand is what I'm saying, okay? I didn't say that right. Bring out any factor of the radicand that is under the radical that you can, okay? Bring it out and put it in simplified form. Don't forget what a conjugate is, okay? Conjugate is also an important property for chapter 10. So I will probably emphasize more the trigonometric ratios from chapter 10. And then finally, chapter 11, where we have been at in the last few days, inverse variation. Remember, y varies inversely with x. Y equals k over x. And k then is x times y. So x1, y1 equals x2, y2. Inverse variation. And then, of course, rational functions and expressions, simplifying them, adding and subtracting, multiplying and dividing. Know what an excluded value is from the domain. What do we exclude? Anything that gives a 0 in the denominator. If we're solving for a root and we find an answer that is a 0 in the denominator, then, or that creates a 0 in the denominator, then that is called an extraneous root and we do not include it. So know how to multiply and divide expressions, okay, rational expressions, and also be able to solve equations that involve rational expressions, okay? So go over chapter 11. So this is the material that will be on your test. We're talking about chapter 8, factoring, 9, 10, 11. Okay, 3 chapters basically, and factoring. Okay, so that pretty much wraps it up. Let me suggest to you that it would be really good if you would watch like 1 video a day between now and next week, or 2 even. Watch a couple of videos a day. You can get them all done. If you do that, just start watching those videos and refreshing yourself. The videos will, I think, do a good job of reviewing you. And if you know what's on the video, I guarantee you, you're going to get a really good grade. So I've been toying with this idea, I may give you FaceTime with me as individuals, one-on-one, where I ask you a few questions, and then we'll talk about how you would solve a particular problem. I might give you a problem and say, how would you solve this? And then you will describe to me what you would do. Basically, I want to make sure that you guys do not cheat, and don't you dare cheat, and that you do your own work, okay? Study hard, and if I give you an oral test, believe me, I'll know if you've learned anything real fast. So prepare yourself, okay? Prepare yourself. With all of that said, let me wish you a farewell, okay? I have enjoyed having you guys in this class. It's been nice. I've had a lot of fun teaching you. You've been good students overall, and you know, you guys have survived. You made it to the end, okay? And just don't let yourself down on this last test. Do your best and make sure you come out as strong as you can, okay? If you have questions, you can always give me a call. All right, I'm going to put up this video and I'm going to put up an assignment to go with it. The assignment probably won't come until tomorrow morning, but you've got like several days to get it done. So I'll give you plenty of time on this last one. Study hard, do your best, and God bless. Now I forgot how to end this thing. Aha, here's how we end it. All right, bye.